First off, today, let me apologize if my voice is sounding a little rough and harsh, and it might be like that for the next few lessons that you watch, but a little bit under the weather, and wrestling season's kicked in, and I'm doing too much yelling. So, all right, at any rate, lesson 46 today, problem solving using scientific notation. You're going to do some more with scientific notation and some more with the exponent rules that we've learned and practiced here over the last few weeks. We're being asked to multiply these two numbers that are in scientific notation. Okay, we've got 2.4 times 10 to the 6th power. We're going to multiply that by 2.0 times 10 to the 5th power. Well, the first thing we need to understand is that multiplication is commutative, so it doesn't matter what order we do it in. Because of that, I'm going to rearrange all this stuff here. It's also associative as well, multiplication, so I can rearrange this stuff. All right, so I've made this 2.4 times 2.0 times 10 to the 6th times 10 to the 5th. Everything's still there. I'm just doing it in different order in different groups. Okay, well, 2.4 times 2.0 is 4.8. And 10 to the 6th times 10 to the 5th is 10 to the 11th. And we have a number that is in scientific notation, and we are done. If they want me to put that into standard notation, I could do it. No calculator necessary. In fact, a calculator might not be able to handle numbers that are this big, actually. All right, so the next one, same thing. We can rearrange this using properties of associative and commutative. I'm going to do 1.25 times 2, and I'm going to do 10 to the 4th times 10 to the 6th, and I'm going to multiply those together, and that is scientific notation. Okay, 1.25 times 2 is 2.5, and 10 to the 4th times 10 to the 6th is 10 to the 10th. And we have a number that is in scientific notation. Okay, so I think we've, you probably get the idea here. It's pretty quick and easy once you realize that you are allowed to arrange things differently. Okay, we've got an answer that is in scientific notation. We could rearrange this into standard notation if we wanted to. All right, let's do another and throw a little kink in it. 4 times 4 is 16. And 10 to the 5th times 10 to the 5th is 10 to the 10th. All right, this is not scientific notation because we've got a number that's greater than 10 here. We got to have a number that's less than 10. So what I want to do is I want to make that 1.6 instead of 16. But if I change that, I have to change my power of 10. I basically just divided this number by 10. So I better multiply this number by 10 in order to keep things kind of balanced out here. Okay, now that is scientific notation. We get a number less than 10 times a power of 10. Let's do that one more time here, and hopefully you'll understand what I'm doing. 2.5 times 5 is 12.5, and 10 to the 6th times 10 to the 7th is 10 to the 13th. That's not scientific notation because I've got a number bigger than 10. I want to leave my answer in scientific notation. So I'm going to move the decimal place one spot to the left. Okay, I made that number look smaller. I'm going to make this number bigger. That's probably the easiest way I can explain it. If you make this number smaller, this 12.5 smaller, make it into 1.25, you better make this one bigger to compensate for that. We'll do that again here in a little bit. Okay, one day is 86,000 seconds. Well, first of all, actually, I wrote down the wrong number. It's 86,400 seconds. Express this number in scientific notation and estimate how far the sun's light travels in a day. Okay, so first of all, there's a necessary piece of information you need to know here, that the speed of light is 300,000 kilometers per second. That's a very necessary piece of information. Next, we're going to write 86,400 in scientific notation. That's 8.64 times 10 to the 4th. Okay. Then, to convert this into, to find out how far it travels in a day, we'll say, okay, look, light travels at this speed, 3 times 10 to the 5th kilometers per second. All I did was take 300,000 and I turned it into scientific notation, kilometers per second. Notice how the seconds cancel out. So what we're going to do is multiply these two numbers. 8.64 times 3 is 25.92, and 10 to the 4th times 10 to the 5th is 10 to the 9th. Again, I'm not going to leave my answer like this. That is not scientific notation. Let's make it 2.592 times 10 to the 10th kilometers. Okay, so what operation have we used for the exponents in problems A through E? We've been multiplying scientific notation numbers. And what did we do with the exponents every time? We were adding them. Because when you multiply numbers at the same base, in this case the base was always 10, we add the exponents. Moving on. Now we're being asked to divide. Well, it's a very similar process. We're going to look at this as 3.6 divided by 3 and 10 to the 10th divided by 10 to the 6th. 3.6 divided by 3 is 1.2, and 10 to the 10th divided by 10 to the 6th is 10 to the 4th. We've got a number that's in scientific notation. I used a calculator here. I'm not going to lie to you. 3.6 divided by 3 is 1.2. Over here I did not. I know what 10 to the 10th divided by 10 to the 6th is. Let's do that again here on H. I'm going to look at this as 6 divided by 4 times 10 to the 8th divided by 10 to the 8th. All right, 6 divided by 4 is 1.5. No, I didn't need a calculator for that. And 10 to the 8th divided by 10 to the 8th is 10 to the 0. And that's it. All right, so let's do this 2 more times. 1.2 divided by 3. That is, I'm using a calculator here, 0.4. And 10 to the 7th divided by 10 to the 3rd is 10 to the 4th. This is not scientific notation. To be scientific notation, I have to have a number greater than 1, or greater than or equal to 1 right here. So what I'm going to do is I'm going to move the decimal place one spot to the right. I'm going to make that 4. Okay. Well, if I make this number bigger, I multiplied it by 10, I better make this number smaller. Let's divide it by 10. 10 to the 3rd. A little bit different than what we did before, but a little bit the same. I'll show you that one more time. Okay, 3 divided by 8 is 0.125. I'm sorry, 0.375. And 10 to the 9th divided by 10 to the 4th is 10 to the 5th. This is not scientific notation because this number right here has to be 1 or greater. It's got to be between 1 and 10, basically. So let's move the decimal place one spot to the right. And that changes the exponent of our power of 10 as well. Move it one spot to the right. I got to change my power of 10 by 1. Okay, I made this number bigger. I want to make this number smaller to balance it out. If Mars is 225 million kilometers from the sun, how long does it take light from the sun to reach Mars? Well, first of all, let's think of 225 million in scientific notation. That's 2.25 times 10 to the 8th. Next, let's take that number, which is kilometers, by the way, and let's multiply it by the reciprocal of the speed of light. Because remember, in 1 second, light can travel 3 times 10 to the 5th kilometers. That's just the reciprocal of what we've done. And the reason I use the reciprocal is, look, I wanted kilometers to cancel out, and I want my answer in seconds. Okay, so we're going to do 2.25 divided by 3, which is 0.75, and then we're going to do 10 to the 8th divided by 10 to the 5th, which is 10 to the 3rd. I don't need a calculator for that. That's not scientific notation, so let's adjust it. Let's make it 7.5 times 10 to the 2nd power seconds, which, by the way, is about 750 seconds in standard notation. Lastly, what operation did we apply to the exponents in problems G through K? Well, we were dividing powers of 10. So what did we do with their exponents? We subtracted. When we are dividing numbers at the same base, we subtract their exponents. All right. I've been told that every night I say the same thing at the end of our lesson, so I guess I'll just say it again. Have a great night. See you tomorrow.